Hi everyone. In this video lecture, we're going to cover PowerPoint Lecture 5, which is also Chapter 5 of your book. So Lecture 5 will cover the first part of Chapter 5 and Lecture 6 will cover the remaining portion of Chapter 5 in your book. The first part of Chapter 5 talks about the price elasticity of demand. So we are going to cover that. We're going to understand what is the price elasticity of demand, and we're going to understand the different types of price elasticity of demand. We're going to look at how it can be calculated and what are the different determinants. In the next lecture, we're going to learn about price elasticity of supply, cross elasticity of demand, and income elasticity of demand. So moving on, the first thing, what is elasticity? When we say price elasticity of demand, what does it mean? What it means is basically what is the responsiveness of demand to a change in price. Okay, so how much a demand will change when there is a change in price. That is what is known as price elasticity of demand. Basically, it is the measure of responsiveness of quantity demanded to a change in price. Okay, for a good, right, or for a service. Now when there is a price change, let's say for salt, we will react differently compared to when there is a price change to to hamburgers. Okay, so that's what it is all about. How, as consumers, how do we respond to changes in prices of different types of goods? And that's what the price elasticity of demand measures. Okay, now there are different types of price elasticity of demand. Like in economics, we have divided price elasticity of demand into different types, so it's easier to understand how we react when there are changes to prices for certain types of products. Okay, so first is the elastic demand. That's the first type. Elastic demand is basically, it's a sensitive response by consumer to price changes. So when we have an elastic demand, what it means is the percentage change in quantity demanded is greater than the percentage change in price. Okay, so whenever we are going to have the percentage change in quantity demanded is greater than the percentage change in then price, then it is called elastic demand. An example would be when there is a change in price for used clothes, or when there is a change in price for used automobiles, we will react more sharply to it because we are more sensitive to the prices of these type of products. Okay, so again, just in numerical terms, what it means is, let's say the price of used cars go up by 1%, probably the quantity demanded for those cars will go down by 2%. So the percentage change in quantity demanded is greater than the percentage change in price. And again, it will be in the opposite direction, because price and quantity demanded, or price and demand, are negatively related or inversely related because of the law of demand, as you know from previous lectures. The second type is called inelastic demand. Inelastic demand is, yeah, we are sensitive to the price changes, but we are insensitive to the price changes. We are not very responsive when there is a change in price for a particular type of product. Okay, so again, under this inelastic demand, we are going to have percentage change in quantity demanded will be less than the percentage change in price. So let's say the price of salt goes up by 2%, but the percentage change in quantity demanded for salt will only fall by 0.5%. Okay, so that is inelastic demand, when we are insensitive to the changes in prices, and the percentage change in quantity demanded is actually less than the percentage change in price. Example would be, medical expenses, gasoline prices. These are necessities in our lives. Even if the gas prices go up today, we have to buy gases in order to go to work, in order to go to school. So regardless, we have to buy this. So our changes, or the percentage change in quantity demanded, is very little compared to the percentage change in price. So that's inelastic demand. Okay, now there's another one in between elastic and inelastic. In between these two, there's one more that is called unitary elasticity. Unitary elasticity happens when the total revenue does not change. The total revenue remains the same whether the price increases or decreases. Okay, so total revenue will not change for the producer when they are selling products and they increase the price. The change in revenue, there will be no change in revenue. Okay, so that's why it's called unitary elasticity. In other words, when basically the percentage change in price of a good is equal to the percentage change in quantity demanded, we are going to have unitary elasticity, and at that time the total revenue to the consumer or to the business will be the same as before. Okay, so elastic demand is when percentage change in quantity demanded is greater than the percentage change in price. Inelastic demand is when percentage change in quantity demanded is less than percentage change in price, and unitary elasticity is when percentage change in quantity demanded is exactly equal to the percentage change in price and total revenue remains by the same. So if price goes up by 1%, quantity demanded will go down by 1%. They are exactly equal and total revenue does not change. Okay, now there are extremes of elastic and inelastic, and that is known as perfectly elastic demand. That's basically the percentage change in quantity demanded is infinite and the coefficient of elasticity is infinite in this case. And for perfectly elastic, the percentage change in quantity demanded is zero. There is no change at all. Whenever there is a change in price for a good that has perfectly inelastic coefficient, there will be no change in demand. Consumers will not change their quantity demanded, and therefore the percentage change in quantity demanded is zero with the change in price. Okay, totally non-responsive to changes in prices. So these have different demand curve shapes, and I'm going to draw that shortly, but I want you to remember these two things. We are going to learn how to calculate the coefficients, but if I say a product is perfectly elastic, then the coefficient of that product is infinity. Okay, so if a product has a perfectly elastic coefficient, then that is equal to infinity. Now if a product has perfectly inelastic coefficient, then that coefficient is equal to zero. Okay, so always remember that, keep it in mind. Perfectly elastic demand is equal to infinite coefficient, and the demand curve will be a horizontal demand curve. Okay, and perfectly inelastic demand when we have that, we have a coefficient of 0 and the demand curve will be vertical. Okay, let me draw it and explain it to you. Okay, let's say I first want to do this table so you understand, or I first want to do this line so you understand. So let's say we have a line. In the middle we will have unitary. Okay, unitary elasticity. Okay, and unitary elasticity, it will be 1. The coefficient will always be 1. Okay, and we're going to look at it a little bit later on, but basically under unitary elasticity the coefficient will be 1. To the left of unitary elasticity we are going to have inelastic demand. Okay, and at the very end, the far extreme is perfectly inelastic, and this is 0. The coefficient is 0. Here it's 1. Here is 0. Inelastic will have something in between 0 and 1. Okay, so somewhere in between 0 and 1 will be inelastic. On the right hand side we will have elastic when we are more responsive to changes in prices for a good, and at the very end of the line we are going to have perfectly elastic demand. Okay, and this will have a coefficient of infinity, and here between unitary elasticity and perfect elasticity we are going to, anything in between that will be elastic. 2, 5, 10, 11, 100, then we are going to have a elastic demand. Okay, so hopefully this line gives you a clear understanding of the different elasticity. At the very end on the left side we have perfectly elastic. In that case we are going to have a 0 coefficient. Then in the middle, right in the midpoint, we are going to have unitary elasticity, which is 1 in between unitary and perfect elasticity. perfectly inelastic, we have inelastic demand. And then on the other right hand side, very end, we are going to have perfectly elastic demand, which has a coefficient of infinity, and in between unitary and perfectly elastic demand, we are going to have elastic demand. Anything greater than 1 is basically elastic demand. Okay, and again, remember we said when we have perfectly inelastic demand, the demand curve will look like this. Okay, again, this is price, this is quantity, and this is demand curve. So no matter what the price is, your quantity demanded will remain the same. We are totally irresponsive to the changes in prices. Okay, on the other hand, for perfectly elastic demand curve, it will be a horizontal curve. Okay, so anytime there is a change in price, quantity demanded will fall to 0. Okay, so that's why it's infinity. Okay, there are people will not buy the good if there is any increase in the price or decrease in the, and decrease in the price is not necessary because producers will not make money. On the other hand, if they increase the price, producers will just stop buying that good altogether. So that's why it's 0. Okay, so that's how the perfectly, so I can ask you what will be the shape of a perfectly elastic demand curve? It will be horizontal. On the other hand, what will be the shape of a perfectly inelastic demand curve? It will be vertical. Okay, so hopefully this helps you to understand what we mean by elasticity. Now there are two methods to calculate price elasticity of demand. First one is called the total revenue test. The second one is called the coefficient of elasticity. We are going to look into both of them, and these are very important. You need to know each method will determine if a price change. So using the purpose of these methods is to determine when there is a change in price, if the demand is elastic or if the demand is inelastic or if the demand is unitary. So that's what our purpose is. Using these methods, we will figure out if the demand for let's say salt, or let's say for sugar, is elastic or inelastic or unitary. That's the main purpose. Okay, so the first method is called the total revenue approach. It is the easiest way to calculate price elasticity. It basically compares the direction of price change with the direction of total revenue change. Now when we are talking about total revenue, that's the money, or that's the total sales that the businesses are making when they are selling the good. Okay, so if the price and revenue change in the same direction, so if price is going up and revenue is also going up, in that case price is inelastic. Or if price is going down and revenue is also going down, then the quantity demanded is inelastic. Okay, an example would be public college increases tuition prices. If tuition prices will go up, your total revenue will also go up, because everyone will have to go, and most people will go and finish their college work, right? On the other hand, if the price increases but total revenue decreases, or vice versa, so if prices and total revenue change in the opposite direction, then elasticity of demand is elastic. Okay, then it's elastic. Example would be the price of airline travel, right? If the prices of airline travel go down, we will probably go for more vacations. If the price of airline ticket goes up, we will probably not go for tickets. We will probably not go for vacations. And on the other hand, if the price goes up but total revenue still remains the same, then we are going to have unitary elasticity. Okay, or if price goes down and we still have the same amount of revenue, then we have unitary elasticity. So based on the direction of the change between price and total revenue, we can determine if the elasticity is if it's inelastic, if it's elastic, or if it's unitary. Okay, so now I will do a table to give you an example using the total revenue approach, so it's clear to you guys. And it's pretty straightforward, but I want to do it so you guys understand what's going on. Okay, so let's say we are given with price for a product. We are given with the price, quantity demanded, then we have to figure out the total revenue, and we have to tell if it is elastic or if it is inelastic. Okay, let's say the price is $10. When the price is $10, only 1% will buy it, or only 1 unit will be bought. So what is the total revenue in this case? Total revenue is price times quantity, right? 10 times 1, so your total revenue is $10. Okay, now let's say your price decreases to $9, but quantity demanded actually goes up to, sorry, I was about to put a dollar, but it should be, okay, so now let's say because price went down, more people are going to buy it, so 2 units of the good will be bought. So it's 2, but now what will be the total revenue? Price times quantity demanded. So total revenue is now going up. So what can you say here? Your price is going down, but your total revenue is going up. So they are in the opposite direction, correct? Price going down, revenue going up. So this is elastic. At this portion, we are going to have elastic demand. Okay, now let's move on with the table. Let's say the price again drops to $8, and now the demand increases to $3. So total revenue is 8 times 3, which is 24. Again, in this case, your revenue went up, but your price decreased. So we are still going to have an elastic type of demand. Okay, now let's move on. Price falls to $7, and then quantity demanded to 4. Then price goes to $6, quantity demanded to 5. Let's keep moving. 5, 4, 3, 2. I'm sorry, I made a this should be 6, 7, and this should be, let me correct the, okay, let me correct the table. 6, and this should be 4, and this should be 7. Okay, so let's say we're given with this table. Now we calculate the total revenue, which is price times quantity. So 7 times 4 is 28. Again, price went up, price went down, total revenue went up in this case, right? So we still have elastic demand. What's next? 6 times 5 is 30. That's total revenue. Okay, 30. Price went down, revenue went up, still elastic. How about in this case? Price went down, but revenue remained the same. This time revenue did not go up, revenue actually remained the same. So this, although your price decreased by $1, your revenue did not change. So this will be unitary elasticity, because your total revenue remains the same. Total revenue remains same. Okay, and let's move on to the next one. When we reduce the price from $5 to $4, what happens to the total revenue? 4 times 7 is 28. In this case, the revenue also dropped. So now they are moving in the same direction. Price and revenue moving in the same direction, which means demand is inelastic in this case. Okay, so this example will probably help you to understand. Here in the beginning of the table, you will see price is decreasing, but revenue is increasing. So price and total revenue are moving in opposite directions. So that's when we are going to have elastic demand. Then we have a situation where price decreases, but total revenue remains the same, and that is unitary elasticity. Finally, we have a situation when price decreases and revenue also decreases. They are moving in the same direction. So that's inelastic demand. Okay, so again, this is the total revenue approach. Based on the direction of price and total revenue, we determine if it's elastic, if it's unitary, or if it's inelastic. And it's a very easy way to do that. And hopefully this is clear to you guys now. So that's the total revenue approach. Now we're going to move on and look at the coefficient of elasticity of demand, which is the second type of, or second way to calculate the elasticity of demand. Okay, so This measure is basically the degree of price elasticity of demand. It is calculated. Now, under this, there are two ways to calculate it. One is using the midpoint method. The second one is called the percentages method. Okay, and when I will give you a homework, when I will give you a problem in your assignment, or even I will give you a problem in your exam, I will let you know whether to use the midpoint function or whether to use the percentage function. Okay, so let me tell you what is the formula for the coefficient of demand. So for both the methods, okay, so let's say we have two methods, midpoint method, and then we have the percentage method. Okay, these are two different ways to calculate the coefficient of elasticity of demand. Again, we are trying to calculate a coefficient that will help us to determine if it is inelastic, if the demand is inelastic, if the demand is elastic, or if the demand is unitary. Okay, so for midpoint method, the coefficient, which we represent by E, is given by Q1, which is quantity demanded at point 1, minus Q2 divided by Q1 plus Q2 divided by 2. Okay, so that's on the numerator, and again, this is the midpoint method, so that's what we are doing. At the below we have a midpoint, and at the bottom part we are going to have the price. On top part we have quantity demanded, and in the denominator part we have the price, which is oops, that's my mistake. I'm sorry, I'm really sorry. So there you go, back again. So on the numerator we are going to have quantity demanded, and on the denominator we are going to have P1 minus P2 divided by P1 plus P2 divided by 2. That's the midpoint method. Okay, and we also have to take the absolute value of this number. So if it comes out to be a negative number, we do not consider, we will make it a positive number, because we will take the absolute value. That's what we are going to do. We are going to take the absolute value in this case. Okay, because price elasticity of demand cannot go below 0. If you remember at the very end of the line here, if you remember here, the very end of the line we have perfectly inelastic, and the very lowest coefficient is 0. We cannot go below 0, so it cannot be negative. So even if we might have a negative number here, because price and quantity demanded are negatively related, but we will always use an absolute value to determine the elasticity. Okay, so this is the midpoint method, and then we have the percentage method, which is given by elasticity of demand is given by percentage change in price, or change in quantity demanded on the numerator, divided by percentage change in price. Okay, so that is the percentage method, and this is the midpoint method. Again, you have to remember these equations or these formulas. Make sure when you're doing the homework or when you're taking the exam, you have it on your notes, and I will tell you which method to use when you will calculate this. Okay, now a couple of things. If you remember from the slide, I told you before as well, if the demand is inelastic, then the coefficient, then the result is E, this coefficient will be greater than 1. Okay, and up to infinity, it can be up to infinity. Okay, so anytime if it is greater than 1, then the demand is elastic. The higher it is from 1, the more elastic it is. So if the elasticity of demand is 2, let's say for phone, and if the elasticity of demand for TV is 5, that means the demand is more elastic for TVs compared to telephones. Okay, so the higher it is, the more elastic it is, the more elastic the demand is. Now if it is less than 1 but greater than 0, then the demand is inelastic. So remember these things. Okay, and if the elasticity is 1, then it is called unitary elasticity. So I want to write this so you remember this. It's also written in your slide, but I just want to be sure that you understand, because this is very important. So if elasticity of demand is greater than 1, it's elastic. Okay, if elasticity of demand is less than 1 but greater than 0, then it's inelastic. Okay, and if elasticity of demand is equals to 1, then it is unitary elasticity. Okay, and then remember also, if elasticity of demand is 0, that is perfectly inelastic. Remember the line I did in the very beginning. And then if elasticity of demand is infinity, then it is perfectly elastic. So this is a guideline you can use to determine if the demand for a particular type of good is elastic or inelastic or perfectly elastic or unitary. Okay, so keep this in mind. Once you calculate using the midpoint method or percentage method, you will get a number. Okay, and you have to use a positive number, absolute advantage. Okay, so you have to always use the absolute number, and it has to be greater than 0. And based on this criteria, you can define if the demand is elastic or inelastic or unitary. Okay, so let me do a quick example so you guys understand how to do it. Okay, now I will do an example using the midpoint method in this case. But let's say you're given with a graph, a demand line. This is price, this is quantity demanded. Then you have a demand curve and you have couple of points. Okay, at A you have the price is 60. Then you have B, price is 50, quantity demanded is 100. Then you have point C. Point C is 40 price and demand is 200. Okay, then you have point D. Okay, and that's, let's say, is 30. And then here you have 300. And let's say you have point E at the very end, which is price is 0, but let's say demand is 600. Okay, so let's say you are given with this graph, then I ask you to calculate the coefficient of elasticity of demand. So what is your coefficient of elasticity of demand using the midpoint method? So see, I will tell you which method to use in your homework or your exam, so you know which formula to use. Okay, so now in this case we know we have to use the midpoint method, but I give you more information. What is your elasticity of demand when we move from point B to point C? Okay, so when we move from here to here, what is your elasticity of demand? Is it inelastic, or is it elastic, or is it unitary elasticity? That's what we are going to try to find out. Okay, now again we know the formula. ED using the midpoint method we know is Q1 minus Q2, okay, divided by Q1 plus Q2 divided by 2. That's on your numerator. Then on your denominator we have P1 minus P2 divided by P1 plus P2 divided by 2, and we take the absolute value of this number. Okay, so we have that. Now we look at the coordinates at point B based on the graph. Okay, based on this graph, point B is price is equals to, which is P1 is 50, and quantity Q1 is equals to 100. Okay, then what about C? C is P2, which is equals to 40, and Q2 equals to 200. Okay, now we know P1 and P2, we know Q1 and Q2, so let us calculate the elasticity of demand using the formula. Okay, so the easiest way to do this is first calculate the numerator, then you calculate the denominator, and then you can divide the numerator and denominator to find out the end result. Okay, so numerator, we look at the quantity demanded first. So Q1 minus Q2 divided by Q1 plus Q2 divided by 2. Okay, so we end up with 100 minus 200 is minus 100 divided by 200 plus 100 is 300 divided by 2, or in other words we end up with minus 100 divided by 150, or we can also say minus 2 by 3. Okay, so that's the numerator. We end up with a negative number minus 2 by 3, but remember we will always take the absolute number, but we'll do that at the very end. Okay, then we calculate the denominator. Okay, so let's now calculate the denominator, which is the price per part. Okay, so denominator will be P1 minus P2, which is 50 minus 40 divided by P1 plus P2, 50 plus 40 divided by 2. So that is equals to 10 divided by 50 plus 40 is 90 divided by 2, or we have 10 divided by 45, or we have 2 divided by 9. So that denominator is 2 divided by 9 and the numerator is minus 2 by 3. So now finally we calculate the elasticity of demand, which is gonna be absolute value of the numerator minus 2 by 3 divided by 2 by 9. So if we convert that, it comes out to minus 2 by 3 times 9 by 2. 2 cancels out, we get 3, so we have minus 3, but we take the absolute value, so the value of elasticity of demand is 3. So based on the criteria, it is greater than 1, so demand is elastic in this portion of the graph. Okay, so again, if you follow the steps properly and if you know the guidelines, you will be able to tell when a particular point on a demand curve if it is elastic or inelastic. Easiest way is first calculate the numerator, then calculate the denominator, then plug in the numerator and denominator, get the value, then just use the absolute value. We don't take the negative value. Okay, and here is 3 greater than 1, so that means it's elastic, means for this type of good people are responsive, or people are more sensitive to changes in prices. If price changes by 1%, quantity demanded will go down by 3%. That's what it is telling. Okay, that's what this coefficient is saying. If price goes up by 1%, the quantity demanded will go down by 3%. So hopefully that example was helpful. Usually the prices are more elastic on the upper end of the demand line. So again, if we go up here on the demand curve, we are seeing here what it's basically saying is, usually on the upper part it's more elastic, and in the lower part it's more inelastic. Okay, so that's what it's trying to tell you. Okay, Now, then we have given you some price elasticity of coefficient for price elasticity of demand for some goods like salt is 0.1. That means the elasticity is inelastic, meaning if there is a change in price, if price goes up by 1%, quantity demanded will only fall by 0.1%. Coffee is 0.3. These are necessity items, so we are not that sensitive to the changes in prices. Okay, then doctor services, which is medical services, it's also necessity. Private education is 1.1. It's a little bit expensive. We don't need to take private education. We have an option for public education, so that's why it's elastic. When there is a change in price, increase in price, we'll probably move to public education, and therefore we are more responsive, or we are more sensitive to changes in prices. Restaurant, again, if the restaurant increases the price of meals, we will probably not buy from that restaurant as much. Same airline travel. Okay, so a price elasticity coefficient describes the expected changes in quantity demanded when 1% change in price occurs. Again, what I said, if elasticity of demand is 3, that means if there is a change in price by 1%, the quantity demanded will fall by 3%. Okay, again, if you have an example, if you are given with elasticity of price elasticity of demand is 1.7, what it means is if price goes up by 1%, then quantity demanded will fall by 1.7%. Okay, let me do another quick example so you guys are more clear on this. Okay, so let's say you are given with a coefficient of elasticity, price elasticity of demand equals to 2. Okay, so basically we are given with ED is equals to 2. Now I ask you, by how much will your quantity demanded change if price rises by 5%? Okay, so based on the ED, we know that when there is a 1% increase in price, it will cause a 2% decrease in quantity demanded. So when we have a 5% increase in price, we are going to have 5 times 2%, which is equals to 10% decrease in quantity demanded. Okay, so that way we can know what it is. What will be the percentage change in quantity demanded when there is a percentage change in price by 5% or 6%. Okay, so that was pretty straightforward. So moving on, what actually determines that elasticity? Why for some products we are inelastic in reaction, whereas for other products we are more sensitive to changes in prices? What are the reasons that we act like this? Okay, so there are a couple of reasons. First of all is the availability of substitutes, right? Okay, if a product has a lot of substitutes, meaning there are a lot of replacements for that product, we are going to be more elastic, right? Let's say Coke. If the price of Coke goes up, we will probably switch to Dr. Pepper, or we will switch to Pepsi, right? So there are many substitutes. Therefore, the elasticity for Coke will be elastic because there are many alternatives for us. So we can quickly switch to the other ones for which the price has not changed. So that's one of the determinants, availability of substitutes. If there are more substitutes available, then we are more elastic. If less substitutes are available, then we are inelastic. Okay, then whether the good or service is a luxury or a necessity. Again, if it is a necessity, no matter what, if the price changes, we have to buy it. So we are inelastic in this case. Like gas prices, we are inelastic. Medical services, if we are sick, we have to go to the doctor even if it is expensive, right? So inelastic in that case if it's a necessity. On the other hand, luxury, airline travel, if the price of travel goes up, we will probably delay our vacation until the prices go down again, right? So luxury, the demand is elastic. It's not a necessity. The third one is the percentage of the total budget spent on goods and services. Okay, let's say basically the percentage of total income you spend on that particular good or service. So let's say your total salary in a month is $3,000 and your rent is $1,200. Okay, now your rent jumps up to $1,500, so you will be more sensitive to rent. On the other hand, let's say every month you buy a bottle of salt for $1. Now the price of salt goes up to $2. You will not be that much sensitive to that price change, right? Because the portion of the portion of spending on salt compared to your total income is very little, so that price change does not affect you much, so that's why you're inelastic. On the other hand, the rent, when there is an increase in rent, the portion of your total income you're spending on rent is going up. It's going up by a large percentage, right? So you are more elastic, you are more sensitive to that changes. Okay, so if you are spending a bigger amount of your total budget on a good, you are more elastic. If you are spending a small amount of your total budget on a particular good and services, then you are more inelastic. Then the time is also important. How much time you're spending in order to buy a good. Okay, let's say we go to a shop and we just pick up one Morton salt. We're not spending much time, we just know which salt to go, we are going to buy and get. But let's say we go to Macy's and we are trying to buy or pick a shirt. We are going to look at Macy's, we're going to look at Dillard's, we're going to look at JCPenney, right? So that means the more time we spend for shopping, in that case we are more elastic for that type of good. For shirt, we are spending more time for shopping, so that means we are more elastic to the changes in prices. Whereas for salt, we're just going to Walmart and picking it up, we are not spending too much time there. Okay, so that's, in that case, the demand is inelastic. And finally, the amount of time needed to adjust to a price change. So an example in this case would be, let's say gas prices go up substantially. In the short run, you will have no option, you will still have to go to work and school, right? So you will still buy the gas at the high prices, but in the long run you will probably think about buying a more energy efficient car, or maybe Tesla, which uses electricity to run the car. Therefore, you may be price elastic now, but in the future you can become price elastic. So these are the 5 determinants of elasticity: availability of substitutes, then whether the good is a necessity or luxury, then the percentage of the total budget spent on goods and services, the time you spend on shopping for a particular good, and the amount of time needed to adjust to a price change. Okay, now this slide gives you some real life examples of price elasticity of demand. Agricultural products or farm produce such as eggs and eggs or other cabbage, we are inelastic. If there is a change in price, we will still buy that good. Okay, then on the other hand, luxury goods such as yachts, we are elastic. If the price goes up, because if the government puts a tax or something, we are not going to buy yachts probably right now. Okay, illegal drugs, it is considered inelastic. On the other hand, minimum wages are considered price elastic. If minimum wages go up, firms will hire less labor because their cost of production will go up if they hire more people. So they will hire less if the minimum wage will go up. Okay, and at the very end, I'm now going to do a table that will basically summarize what we just talked about, and it's also there in your book, but I wanted to go ahead and do it so you guys are clear on the elasticity of demand side. And today we are just going to finish the elasticity of demand. Next class we're going to look at the supply side and other factors such as income and substitute factors. Okay, but let's look at the table. Okay, so let's say we have demand elasticity, okay, then we have elasticity coefficient, then we have change in price, okay, and then we have total revenue. This is a kind of a summary. Okay, so if the demand elasticity is elastic, then we know the coefficient will be greater than 1, correct? Right. If there is an increase in prices, then your total revenue, what will happen? The percentage change in quantity demanded will fall by a greater percentage, so total revenue will decrease. Okay, again, if it is elastic and ED we know is greater than 1, and if the change in price is decreasing, then total revenue will increase. because your quantity demanded will go up by a greater percentage, therefore you will make more revenue. If it is unitary, in that case the equation will be equals to 1. So if there is an increase or decrease, no matter what, whether the price increases or whether the price decreases, the total revenue will remain the same. Okay, and finally we have inelastic. And inelastic is between 0 and 1. If there is an increase in price, then your revenue will also increase. And again we have another inelastic category where it's between 0 and 1, and if there is a decrease in price, our total revenue will decrease. So this table, again, if you follow this table closely, it will help you to understand the coefficients. It will help you to understand how the total revenue will change with changes in price, and when can we define it as elastic, when can we define it as inelastic, and when we can define it as unitary. Okay, so that's the end of this lecture. I'm going to stop here. Next class we're going to start from lecture 6. Okay, thank you very much. You guys stay safe. Bye.